Testing sound. Okay. Okay. Good afternoon. Good afternoon. Online students, is my audio clear? Yes. Okay. All right. It seems students are still joining in, so I'll wait for another 2 minutes and we'll start. Right. So I'll give you 2 minutes before I start. Quickly go through the linear motion parts we have covered because today we are starting projectile motion. Projectile motion is actually it's the next step, next stage of linear motion. It is like an extension of linear motion, right? So therefore, from linear motion equations, uh, skim through, go through the parts we have covered in linear motion quickly, right? Since students are joining in, I'll wait for another 2 minutes. So until then, you can go through the things we have covered in linear motion. Because projectile motion is very much dependent on that, right? On linear motion. Okay. Good afternoon again. So we'll start, and as we planned, today we are starting a new lesson again, new part again, that is projectile motion, right? That is projectile motion. Take down the heading as projectile motion. Projectile. Projectile motion. Projectile motion. Projectile motion. Right? Take it down. Projectile motion. Right. Before 15, your results are coming, right? Before 15 in the sense, I think now today it's 9th. It's 9th. I think around 12, 13. Before 15 means that is not going to be 15, right? Or maybe before that, right? Results will be released, and they have declared that they are releasing before 15th. But according to my understanding, I think it should be around 12 or something, right? So results are coming. Results are coming, right? So you are waiting. You are eagerly waiting for results. No, right? right? So that is one of the milestones you had in your life, like O levels. That's actually the now if you consider grade 5 scholarship as well, then that's the second milestone you had, O levels, right? But compared to O levels, when it comes to the significance of A levels, that is like to the 99 power of O levels. Let's see value here. Let's say now O levels is the value, and the gravity of the exam is x. Gravity of the A level exam is like x to the power 99. X to the power 99, not times x to the power 99. And in the same manner, the workload is also changing. So which means if you do a workload of, let's say, x for all levels, you put an effort of x for all levels. Here, with this same factor, you have to multiply your effort, right? So that's the thing. That's the thing. Because when it comes to the competition of A levels, that is not something artificial. That is not something man-made. So naturally, the competition is because of the number of opportunities you are exposed after A levels, right? So that's why the exams are that much competitive, and that's why students are putting like their maximum effort to go through the exam, and that's why A levels has become the most the valuable and the significant milestone in life, right? So that's it. It's very critical. That's the most critical and the crucial milestone and the turning point of life if you go through A levels, right? That is how it is, right? It totally changes your path, your career, right? Your path, in which path you are going to go in your life after A levels, right? That is totally depending on your A level result, right? That is why, that is how the competition is naturally made, right? Now, as an example, now if you let's say you are entering to University of Moradua, Faculty of Engineering after A levels, right? So any of the other universities can't beat the value of that degree has. That's the thing. Now, if needed, we know you have the other universities that they are having same engineering degree, and plus as the last option we have private universities as well. But the highest ranking for engineering is here in Sri Lanka is for engineering degree offered by University of Moradona. So therefore now if you got it, which means I don't say the other degrees are not up to that level. No, that's not the thing. But somehow over the years now, like past 15, 20 years, the highest SH score is for University of Moradona Engineering. That is not changing because that's the competition and that's the value that has created with the degree, right? With the degree in the sense that is totally depending on the number of opportunities, number of job opportunities that we are exposing, that we are open up to after getting the degree. So that is how a degree is ranking, right? That is how the set score is increasing, because if more number of students with higher set scores are applying for that degree, automatically that set score goes up, right? If no one applies, it goes down, right? So I'll explain how that preference and set scores are working when we are going to universities later, right? Not today. So just know that that's the thing. So if you entered, let's say, University of Monaco Faculty of Engineering, no any other degrees here in Sri Lanka can beat the value of that degree. That's the thing. That's the thing. That is irrepressible. That is how that competition is created, has created, right? Okay, so all results are coming up. So by next week, definitely you will get your results, no? Because if they declared that they are releasing the results before 15th, no? Yeah, before 15th. Now today is 9th. Next week will be 16th, right? Next Wednesday is 16th. So definitely you should have got your results by next week, right? So whatever the result you have got, nothing to worry. And when it comes to A levels, there are like upside down A level results in both ways, either ways, when it comes to A levels. So whatever the effort you put here for A levels will reflect to A level result, right? So therefore, now I'm just saying, even before releasing your results, if whatever the result for levels that you have got, sometimes it may be something you have expected, or sometimes it will be a result which is higher than your expectation. That's also happening. And sometimes it may be a result which is a bit lower than what you have expected, right? So those are the things happening now. Whatever the result that you have obtained for levels is not going to matter. I mean, there's no direct impact on A levels, because your A level journey is totally about how you work in A levels, right? Not in O levels, right? So therefore, getting 9 A's doesn't mean you are getting 3 A's in A levels, no, right? There are results like 9 A's for O levels and 3 F's passes for A levels. Such results are there, right? So what it reflects is that particular student has not put any single effort towards A levels. That's the thing. Because A levels is not going to be easy as O levels, right? Now, after these first first parts of the syllabus, also after measuring instruments, measurements, now we have done linear motion graphs. Now you can see there is something to think always with questions. There is something to do, right? Unlike O levels, you can't parrot and just go there and write it out. No, always with the question, we have something to think at the question, right? And we have to do something with the given context. That is how the questions are made, right? So therefore, keep it in mind. So whatever the result it's going to be for your O levels, that doesn't matter your A level journey. As long as you work hard, you work towards that decided goal of A levels, or the distinct goal of A levels, right? So therefore, some of you might be happy after O-level results, and some of you might be like neutral, and some of you might be not that happy after O-level results if you didn't get what you have expected. But doesn't matter. O-levels is not the life deciding milestone you have, right? That's A-levels. So therefore, doesn't matter what your O-level result is, right? If there is 9 A's, so it's a rank, that's good. That's a good indication. But yet, that is not going to impact on your A levels, right? Now, if you have seniors also, you can talk to them and check whether what I'm saying is correct or wrong, right? That is how it works. And there are students with like average O-level results, just average O-level results, and ending up A levels with ranks 3A's like that. Now, that is totally how they work during this 2.5 years of A-level journey, right? So therefore, nothing to worry or nothing to think about O-level result, and nothing to be worry actually, nothing to be worry about your O-level result, whatever you have got, right? Now, you have to start your A-level journey fresh. Now, actually, you have already started. I'm just saying this because not to demotivate you after your level results, because some of you might not get the expected results. That's the reality. Some of you might get the expected results, right? Now, that happens, right? Because every one of us is not going to get 9 A's, no? So therefore, that happens. But whatever it is you have got, it doesn't matter for your A levels, right? The only thing here is, if you have worked hard, if you have put your maximum effort for this A level journey from day one onwards up to your main exam, up to the A level exam, right? Going through A levels is not going to be a magic, right? But if you skip all your work, and if you procrastinate all the work, and if you wait until the last month, and if you try to study everything during last 3 months of A levels, that is never going to work. That is never going to work, right? That is how it is. So that's why I'm always saying you to do your things in a weekly basis now, right? Weekly basis is the thing. Now always continue everything, and keep doing all these things in a weekly basis, right? Not only in physics, in all 3 subjects, do everything in a weekly basis. Now, as an example, now I think today is our 10th week or something of doing the class, 10th or 11th or something like that, no? Now, by this, let's say this is 11th week of the class, since we have started, right? Now, weekly, now if you have studied for the previous 10 weeks, right? So, which means for some level, maybe for 50%, 60% of a level, you know the previous things we have covered. That is how it should be. Otherwise, if there is zero, now if you can't remember anything from units when we are doing projectile motion, that is not going to work, because now this is just after 2 months I'm talking, and just assume, just think what happens after 2 years of time, right? We are still in unit 2. We have 11 units altogether, right? So that's why this is not something doable overnight. Now, when it comes to O levels, now if you study hard for a month or 2 months of time, last 2 months or last 3 months of time, there's a higher chance of going through, higher chance of getting through O levels. But here, that is not the case. That is not the case, right? So even after your first term exam also, you will see what the level of exam questions are, right? So this cannot be compared with your O levels or O level results, right? So therefore, repeating again, now results will be released within this coming week, right? So before our next class, definitely you should have got your results, right? So whatever the result you have got, it doesn't matter. It's not going to impact your A-level journey, right? So don't worry about that. Just focus on your A-levels and work hard in A-levels, and go through A-levels with flying colors, with ranks, 3 years and everything, right? And once you go through A-levels, again, no one is going to ask you O-level result as well. That's how it is. That's how it is, right? Because if, let's say now I'm saying that I have got 3 years for A-levels, no one is asking what my A-level result is when I'm at University of Monaco, Faculty of Engineering, right? No one is going to ask, right? Doesn't matter. Sometimes we will discuss about our A-level results and set scores, but we don't discuss about our O-level results and grade 5 scholarship marks. No, nothing, right? And after your BSc degree, let's say you are moving to your first job and you are working as an engineer, no one is going to ask you O-level result. Never, right? So therefore, that is not the milestone. A-levels is the critical and the crucial milestone you have in your life, right? That is the life-changing one. That is the life-changing one. It decides whether you are going in engineering path or physical paths, or other than that, if you are just going to satisfy with doing a course or something like that, or maybe IT side. So different paths are there, right? Numerous paths are there, and everything is decided by your A-level result, right? So therefore, it doesn't matter what the result you got for O-levels. Put your fullest effort here for your A-level subjects and work hard during these 2.5 months of time, and by 27, most probably A-levels will be back in August, right? That is taking forward like month by month in these years, no? Right? Because to cover up, to compensate the delay that we had after COVID and everything, right? Now this time 25 A-levels is going to be on 10th of November, and by 26 it will be around 1 month before November. It will be around October. It will be around October or mid of September, and by 26, by 27, most probably it will be taking back to August, right? Then everything will be like streamlined as before. Now the thing is, now O levels are in March or around, right? And now everything is delayed, no? That's why now everything is taking back, and by 27 most probably O levels will be again back in December, and A levels will be in August, right? So roughly you have 2.5 years of time since you have started. Right? Now already 2 months are gone, right? 2 months are already gone, and roughly your A-level journey is 2.5 years. 2.5 years, right? Right. So it's something like a game of a battle of 30 months of time in your lifetime, and it's gonna change your rest of the lifetime. That's how it is. That's how critical these 2.5 years is, right? put your effort here during just 2.5 years of time here and enjoy your life in your own way for the rest of the life. Right? Now you have decided whether you are putting your maximum to these 2.5 years, and if you are going to enjoy the coming up 40, 50 years of life, or if you are going to waste this time during A levels, and if you are going to like struggle in life for coming 40, 50 years, right? That's the thing here. That's the reality here, right? So therefore, with the A level result, definitely it decides your life. It decides your life, right? That's assured. That's guaranteed. That's guaranteed, right? Okay. So by next week, we'll meet with your results, right? So whatever it is, put your fullest effort here for A levels and go through this milestone, right? That's what we need at the end of the day, right? Okay. Let's go to the lesson. Okay, take down the heading as projectile motion. Take down the heading as projectile motion. Projectile motion. Okay. Now, in linear motion, listen. So first thing is, as I said you before, projectile motion is actually going to be like an extension of what you have done in linear motion, right? That is like an extension. So therefore, all the things starting from linear motion equations, basic rules regarding vectors, right? Applying linear motion equations, right? And applying equations section by section, right? There were some things we discussed in linear motion when we are doing questions, right? Everything is going to be used here again. Everything is going to be used here again in a little bit of an advanced manner. Advanced in the sense that is why I said this is like an extension of a next step of linear motion things we have done, right? Okay, simply a projectile motion is something like this. Listen, simply a projectile motion is something like this. If we throw something, this is just an introduction. Look at here. Let's say I have this object and I'm going to throw this vertically upwards with a velocity under gravity. I'm going to throw this vertically upwards with this initial velocity under gravity. Something like this. And it's going to undergo a linear motion. It's going to undergo a linear motion, right? So if this velocity given here at this point is vertical, if this velocity given here at this point is vertical, it is going to undergo a vertical linear motion. That's a vertical linear motion, right? But without doing this, now this is a vertical linear motion. This is a vertical linear motion. It will be back and forth. Without doing this, if I apply an inclined velocity like this, an inclined velocity, still under gravity, because direction of gravity is not going to change. Direction of gravity is always vertical downwards. That is not going to change. If I do the same with an inclined velocity, can you think of what kind of a path it's going to be? Is it linear? Is it linear like this? Then curve. It's a curve, right? It's going to be a curve. So if I apply this kind of an inclined velocity, right? Now, as an example, now without applying this kind of a vertical velocity, I'm going to apply an inclined velocity like this. See, this is how it's going to go, right? So it will be a curved path. This will be a curved path. So this path is going to be something like this. If you throw something, if you throw something with an inclined initial velocity under gravity, right? It undergoes a curved path. Right? Basically, that motion is called a projectile motion. This is not the definition. I'm just introducing you what projectile motion is, because you have seen projectile motions in everyday life, day-to-day life, right? If we throw a ball, right? If someone throws a ball, right? If you are watching cricket or if you are not watching cricket, right? When you are playing, if you are throwing a ball, right? Then that particular path of the ball is a projectile motion. And if you are hitting a cricket ball with a bat and we are hitting a sixer, let's say, right? Hitting a sixer, and that particular path is a projectile motion. And if you have seen playing volleyball, motion motion of the ball from in the either sides of the net and the ground will be a projectile motion, right? Even in football, if the ball is not going along the ground, right, that's a projectile motion. Now there are kicks, they are traveling in air with a swing and going into the goal, right? So they are projectile motions. So likewise, any motion under gravity, especially and most importantly, with an inclined initial velocity, is going to be a projectile motion. With an inclined initial velocity. Otherwise, if there is a vertical initial velocity, there will be a vertical linear motion. If there is an inclined velocity, inclination can be to this side or whatever it is, under any inclined velocity, it will be a projectile motion, right? And this path has a defined name. This curve actually. This curve is called a, any path can be called a trajectory. Have you heard the word trajectory? No? Path is called a trajectory, right? And this curve is, now when it comes to curves, the reason is this. When it comes to curves, we have different types of curves. Circle is also a curve. Ellipse is also a curve, right? And parabolas are also curves, right? So likewise, different types of curves are there. Then when we say a curve, we have to be specific which type of a curve this is, right? So therefore, this type of a curve is going to be, this is not a circle, this is not an ellipse, this is called a parabola. This is called a parabola. Have you heard the word parabola? Parabola. Have you heard the word parabola? Yes? Online students? Have you heard about the word parabola? Parabola or parabolic, right? Parabola or parabolic. Have you heard? The students on YouTube? Anyone? Others? You should have heard, because I know parabolic curves, parabolic graphs are there in O levels, O level maths, right? The students on Zoom, have you heard about parabola? Parabolas, parabola, parabolic. Heard? Heard? Because you are plotting curves for these kind of variations in O levels, no? Like ax squared plus bx plus c equals 0. For these kind of quadratic equations, you are plotting curves, no? Right? It can be either a maxima or a minima, right? It can be either a maxima or a minima, right? So these shapes are called parabolas. They are the parabolas. That's not a circle. That's not an ellipse. It has its own shape. That's a parabola, right? That is the exact shape of the trajectory or the moving path of a projectile motion. That's a parabola. So therefore, it's also known as a parabolic motion. Projectile motion is also known as a parabolic motion, right? So exactly this path is following this kind of a variation, this kind of an equation, that's kind of a variation, right? So therefore, that is how a projectile motion is defined. How we define a linear motion? Recall quickly. What was a linear motion? Now we have to compare now, because the reason is this. The very first motion we have discussed is linear motion. And this is the second type of motion you are discussing in your journey. And altogether we have how many? We have 6 types of motions. 6. Altogether we have 6 types of motions in A levels. Right? Now we are in the second type. And first 4 types are in mechanics. And the fifth one, simple harmonic motion in waves and oscillations. And the sixth type is a spiral motion, that is in magnetic field. So likewise, throughout the syllabus, we have 6 types of motions, right? Like starting from linear motion, like linear motion, projectile motion, rotational motion, circular motion, simple harmonic motion, and spiral motion. Those are the motion types we have. Now you are in the second type of motion you are learning, right? So first tell me, because we have to always compare and contrast between the thing you know and what you are going to learn today here. I mean, to learn new today here, right? What was the linear motion? What was the linear motion? If an object undergoes in a straight line or a linear path, straight line is a linear motion, right? Here, if an object undergoes in a parabolic path, very simple as that, in a parabolic path under one acceleration. Now, if there are multiple accelerations, it's going to change. So that's why we say under one acceleration, and typically it's only gravitational acceleration. Under one acceleration, if an object follows a parabolic path, that's called a projectile motion, right? Okay, first point, write this down. First point. Now I hope you have got some understanding about what a projectile motion is and what kind of a motion we are going to discuss as projectile motion, right? So basically, that's a motion which undergoes in a parabolic path, right? Parabolic path. Now, if I throw this pen to you, right, definitely it follows a parabola, right? I can't throw this to you in a straight line. Definitely, I can't. The only straight motion under gravity is if a vertical velocity is given. Vertical motion is only the straight or linear motion under gravity. All other motions are going to be parabolic motions, parabolas like this. Okay, write down first point. First point. A motion undergoes. A motion undergoes. A motion undergoes in a parabolic path. Look at here and write if you are not sure about spellings. Parabolic path. A motion undergoes in a parabolic path. Parabolic. Right? Undergoes in a parabolic path with a constant acceleration. With a constant acceleration. With a constant acceleration. Okay, am I audible now? Yes, right. Okay, sorry about that. Small technical issue occurred. I was saying the definition when I missed the connection. Online students? Yeah, some of you have asked about the definition again. Okay, anyway, repeat the definition again. Don't worry, I'll repeat the definition because there was a small technical difficulty, technical issue there. Now it's sorted. Now you can hear me, right? Online students? Can anyone respond quickly? Can anyone respond quickly? Am I audible? Students on YouTube, Zoom. Let me check from my end as well. Okay. Right. So I was explaining the definition, right? So check your definition again. Check definition again if you have missed. So can you repeat the definition? Yeah. I'm going to repeat it. Right? A motion undergoes in parabolic path. This is the word. A motion undergoes in a parabolic path. A motion undergoes in a parabolic path. With a constant acceleration. Along a particular direction. With a constant acceleration along a particular direction. Is called a projectile motion. Right? Okay. Now look at here. The core of projectile motion is going to be here in this explanation. Right? For all the questions coming up, this idea that we are going to get from this now is going to be important. Right? So stop all your work and listen to this explanation. Look at here. Right? Now I'm going to take this object, assume this object, and let's say I'm going to throw this object with an inclined velocity u, right? And it's going to follow this kind of a path in its motion, right? And let's say this is my t equals 0. This is where the motion starts, t equals 0. And again on ground here, and this is where the motion stops, let's say t equals t. That is where the motion is going to be completed, t equals t, right? And I'm going to mark x and y axis here. This is my y axis of the axis panel, and this is going to be the x axis of the axis panel, right? And let's say I have projected this object at the origin, right? This is for our is to identify the motion, right? Now I'm going to do something like this. This is a nice idea we have about a projectile motion. Very nice, very what we call an idea that you can see the actual beauty of physics is here, right? First tell me whether you have heard about the word projection. Have you heard about the word projection? Anyone has heard about the word projection? No. Heard? Any idea about the meaning? Any thoughts about the meaning? I don't need any definitions. Just tell me what do you think about the word, or what do you know about the word projection? Anyone? So you can answer and engage with me. Sorry? Applying force on an object is projection. No. Others? Any different thoughts? Projection. Have you heard about projector? That everyone of you has heard, no? Projectors. So this word is breaking down from projectors. Projector and projection. What's the meaning of projector? Or projecting, projector? Displaying something. Right? Any different ideas? Displaying something. Any different ideas? Any different ideas? No. Displaying something, that's true. What is displayed using a projector? That is where the meaning is in. No. What you are seeing on the screen is actually a shadow of the screen. That's a shadow. Because inside the projector, we have a small bulb with a convex lens. Then with that convex lens, it will be imaged to a screen. That's a shadow. So therefore, from projector, that is why we need a separate screen to get a projection. Right? Thank you. So projection is a shadow. Projection is a shadow. Projector is the equipment you have to create that shadow. Right? So there are different meanings. Explaining the meaning here in projectile motion. Otherwise, projection has another meaning of throwing something. Throw. Projected upwards, throwing upwards. Right? There is also another meaning. Right? So other than that, projection is a shadow. Projection is a shadow. So that is why we call the projector as a projector. Right? Because it falls a shadow onto a screen. Right? So projection is a shadow. Now what I'm going to do is, listen, this is the most important idea here in a projectile motion. What I'm going to do here is, now I'm going to think of the positions, random positions of this object when it is moving from here to here. I'm going to think of the random positions of the object when it is moving from here to here. Right? So don't parrot this. Right? Projectile motion it's like linear motion. Right? Understand the concept. Right? Understand the concept. Understand the concept. Once you got the concept, you can do any question without any hassle. Otherwise, if you're going to parrot this here onwards, definitely after 2-3 questions, when we are moving to average questions and advanced questions, you will get stuck. Right? So understand the concept behind the projectile motion. So that's why I'm going to explain this here. Right? So first, I'm going to think of some random positions, random points of this object when it is moving from here to here. Right? Now what has happened is, it starts a motion from t equals 0 here, and it moves along this path, and it has ended the motion at t equals 3 here. Right? Now if I think of some random points of the motion along the way, random points along the way, right? There are infinite number of points. From that infinity, I'm going to consider few of the points. Right? So let's say after some time, my object is here. After some time, the object is here. Again, here, here, here. And at some point, it is reaching the maximum possible height it can take. And again, on the other side, it is coming back. It is coming back. It is coming back like this. And finally, it will be here. And finally, it will be here. Now, these are the random positions of the actual object when it undergoes this projectile motion. Right? Now, what I'm going to do is something like this. I'm going to consider the shadow on vertical axis and the shadow on horizontal axis. Shadow on vertical axis is called vertical projection. Vertical projection. Now, my vertical axis here is the y-axis. And shadow on horizontal axis is called the horizontal projection. Right? Projection is a technical term. Right? And the meaning is the shadow. Now, if I need to get the vertical shadow, look at here. This is the important part you need to understand. If I need to get the shadow of this object on this vertical axis, right? Just assume, now if I need to get a shadow, if I assume that I'm using a light source from this side, we can think of the shadow now. As an example, if I need to think of the shadow of this pen, right, on that screen, right? What we can think of is, if I apply a torch, if I aim a torch in this direction, the shadow is going to be on the opposite screen, and then we can think of that shadow. What type of a shadow it's going to be? Now for this pen, it will be a rectangular shaped shadow there, right? And if I need to get the shadow here, I need to place this light source from the top. Then what I will be seeing is a circular kind of a shadow. So likewise, we can think of the shadow easily if you think of that you are applying a torch simply, a light source, a torch simply opposite to the particular direction that you need the shadow. Now, if I need vertical shadow, vertical projection, this y-axis is going to be acting as the vertical screen now. Now, if I need to get the shadow on that screen, if I apply a light source from this side like this, a torch from this side like this, I can think of the shadow, how it's going to be on this screen now, right? So let's go point by point. Let's go point by point. Any questions? Let's go point by point. Recording is off. Oh, thank you. Okay, thanks a lot for reminding. Right. Okay. Now, first thing is, this is the first position of this object it has at this point now. Now I'm going to think of the vertical shadow of this object. Vertical shadow. Now, if I need the vertical shadow, if I apply a torch, a light source from this direction, see, the vertical shadow is going to be here. Is it clear? Similarly, if I need the vertical shadow at this point, it is going to be here. And the vertical projection here is at here. Vertical projection here is at here. And vertical projection here is at here. And vertical projection with respect to this topmost point is here. And again, when it is going the second half, when the object moves the second half of the motion, the shadow is again at the same point. This shadow is again at the same point. This is again at the same point. This is again at the same point. Now I considered few random points. This is again at the same point. Right? Now, without thinking of the motion of the actual object, just think of this motion of the shadow, vertical shadow. Just think of the motion of the vertical shadow. When the object is here, shadow is exactly there. When the object is here, shadow is exactly there, right? And when this object goes from here to here, shadow is at the topmost point. And when the object travels the second half, the shadow again returns. It comes down, it comes back, right? It comes back. Clear? So therefore, the motion the shadow has done is linear or projectile. It's linear, vertical, right? To be specific, that's a linear vertical motion. Now, if I draw the direction here, now this is what the shadow has done. This is what the shadow has done, isn't it? This is what the shadow has done. A linear motion, vertical linear motion, right? Now, similarly, I'm going to check about the horizontal shadow. That is called the horizontal projection. Horizontal projection, right? Now, if I need to get the horizontal projection, assume I'm going to apply a light source, a torch from the top like this, from above, right? Now, when the object is here, shadow is exactly there. And when the object is here, horizontal shadow is here. When the object is here, horizontal projection is here. When the object is here, horizontal projection is here. When there is at this point, horizontal projection comes to here. So likewise, keep taking this shadow of the horizontal screen, on the horizontal screen, horizontal direction. So it's going to be something like this. Now again think of the motion of horizontal projection. Linear projectile motion, linear, horizontal linear motion. And there is no return, there is no coming back. This motion is like starting from here and all the way to here. It's all the way to here. But that is still a linear motion. Right? Now what has happened is, this is what you need to understand. Look at here. This is what you need to understand. what has happened is, when the actual object travels from, for my is, let's label this as A, B, and C. When the actual object travels from A to C, look at here, when the actual object travels from A to C, let's say this is D, right? When the actual object travels from A to C along the parabolic path, vertical projection travels from A to D and comes back from D to A in a vertical linear motion, right? And at the same time, when this object travels from A to C in the parabolic path, the horizontal projection travels from A to C in a linear path like this, right? That is what has happened. So first idea here that we can take from this is, projectile motion is a combination of two linear motions. Projectile motion is a combination of two linear motions. Now, once I take these vertical and horizontal shadows, what I see is these two linear motions. When both these motions act together, when both these motions happen together, it undergoes a parabolic path. So therefore, if I think of the vertical direction, that's only a vertical motion. If I think of the horizontal direction, that's only a horizontal motion. But the resultant, the combination of these two is going to be projectile motion, right? So therefore, the first and the most important idea to solve projectile motion questions starts from here. That is, a projectile motion consists of two linear motions, and one is a vertical linear motion, it goes back and forth, and the other one is a horizontal linear motion. And the resultant or the combination motion is called a projectile motion. ඒ කියන්නේ projectile motion එකක් අපි break down කරලා split කළොත් දෙකකට මෙන්න මේ motions දෙක තමයි එන්නේ. මේ motions දෙක තමයි එන්නේ. projectile motion එකක් යවලා මම එයාගේ vertical side එක දිහා විතරක් බලන් හිටියොත් මට පේන්නේ මේක. right? projectile motion එකක යන කෙනෙක් දිහා vertically විතරක් බලනවා. හරි ඒක object එකෙන් බලන්න අමාරු නිසා තමයි මේ shadow එක ගත්තේ. right? මෙයා යන්නේ projection එකේ තමයි. But I'm just thinking of its vertical direction. It's a vertical linear motion. And if I think of the horizontal direction, that's a horizontal linear motion. That is what it reflects by this shadow. Right? So first idea, keep this in mind. First and the most important idea to proceed with the projectile motion is, projectile motion is a combination of two linear motions. Right? That's why I said initially, projectile motion is an extension of linear motion. Because now two linear motions are going to happen at the same time, simultaneously. Right? Now when the projectile motion undergoes in the parabolic path, these two linear motions happen at the same time. Since we already know linear motion equations, right, here onwards what we are trying to do is, we are going to grab the linear motion parts here and apply our equations to solve. Right? Now, if I give you a small idea, maximum height of the projectile motion is the maximum height of vertical linear motion. Is that clear? So likewise, we can compare projectile motion now with these linear motions. And using linear motion, since we already know linear motion, we are going to solve projectile motion. So therefore, there are no any new equations for a projectile motion, because projectile motion is solved using these two linear motions. We already know four linear motion equations. So therefore, none of the equations are going to be coming as new equations here in projectile motion. Right? Okay. First thing, very clearly take this down. Take this down very clearly. Right? Don't draw two small diagrams. Don't draw two small diagrams. Right? So draw it by considering like 4-5 rules with some kind of a large diagram. Operation of projecting. Operation of projecting. Yeah, that meaning is for who's that? Yeah, that meaning is for drawing. Projecting means drawing. Right? So here projecting and projection means the shadow. Shadow. Take it down. You can ask questions if you have anything to know. I mean, anything to know from the things we have discussed so far. If you have anything to know from the things we discussed so far, you can forward your questions. You can forward your questions. Take it down. And if you are using different colors, use different colors, right? And draw a more clear diagram. Parabolic shape is not a circular shape, right? So therefore, actually, if you draw a parabola using the compass, it's not the actual shape. That's a circle, right? Parabolic shape is the parabolic shape. That's the shape of the curve that you are plotting as ax squared plus bx plus c equals 0 curves, quadratic curves. That's the exact shape you are getting in any kind of a quadratic curve. Any kind of a quadratic curve. Forward your questions if you have anything to know, right? While taking this down, if you have any other clarifications to get, you can forward your questions. Take it down quickly. Take it down quickly and mark vertical and horizontal projections clearly. Mark vertical and horizontal projections clearly and mark these two motions like this, vertical linear motion and horizontal linear motion, and then label these points according to mine as A, B, C, D, because I'll be giving you the note based on these points, right? With reference to these points. So don't change the labeling. Label as A, B, C, D as what I have labeled here. This is also a very practical motion, no? Very practical in the sense this is a motion you see everyday life, day-to-day life, right? මොනා හරි throw කරනවා නම් ඉතින් ඒක projectile motion එකක්. If you are throwing something under gravity, right? That's going to be a projectile motion. If you are throwing something under gravity, that's a projectile motion. In most of the games where balls are used, we have projectile motions, right? Cricket is one of the best examples, right? Bowling, batting, throwing balls and everything are projectile motions. Finished, right? Okay. So under this, as the first point, take this down. Under this first point, put an asterisk mark like this, Put an asterisk mark and mention this point, first point. When particle moves from A to C, when particle moves from A to C, in projectile motion, when particle moves from A to C in projectile motion, its horizontal projection along x-axis, travels from A to C, in a horizontal linear path. Travels from A to C in a horizontal linear path. Travels from A to C in a horizontal linear path. Travels from A to C in a horizontal linear path. Travels from A to C in a horizontal linear path. Right? Second point, when particle moves from A to C in projectile motion, when particle moves from A to C in projectile motion, its vertical projection along y-axis, travels from A to D. Its vertical projection along y-axis travels from A to D and comes back from D to A, in vertical linear motion. Comes back from D to A in vertical linear motion. Right? Okay. Now mention this with a red pen. Put another asterisk mark and mention this with a red pen. Therefore, projectile motion is a combination of two linear motions, which undergo in two perpendicular directions. Which undergo in two perpendicular directions. Right? Okay. Look at here. Now, we know when it comes to vectors, we had 4 vector rules, no? Basic rules. What are the basic rules regarding vectors we had in linear motion?
Consider if the motion is the opposite.
Vectors which act into the considered direction are plus, right? And vectors act in opposite to considered direction are minus. And if we have inclined vectors, we have to dissolve them into components. And if vectors are perpendicular to consider direction, they are neglected. They are neglected. They are ignored. Right? Now here, since velocity is going to be inclined, now we have to deal with inclined vectors as well. Right? To deal with inclined vectors, we have a technique called dissolve components. Actually, this dissolve components will be proved under vectors. But before going into vectors, we have to use the result of dissolved components to solve projectile motion. So therefore, I'll explain what is needed as dissolved components here just for projectile motion. Right? But don't worry, the proof of these dissolved components and the initiation of dissolved components will be discussed in depth under vectors. Right? The next lesson coming up is vectors. Right? So take this down as a note. Take this down as a note. This is what is needed from dissolved components to solve projectile motion here. Look at the board. Let's say I have an inclined force like this F. I have an inclined force like this F. This is valid for any vector, right? Don't use a phone. Let's say I have an inclined force. Force is a vector, and this is valid for any kind of vectors. This is valid for any kind of vectors. And let's say the angle with this horizontal axis is theta, and this is a vertical axis. And if this is theta, automatically this angle becomes 90 minus theta because this angle is 90 now, right? Dissolved components means, listen and look at the board. Dissolved components means inclined vectors can be splitted. Inclined vectors can be splitted in two perpendicular directions. Dissolved components is a technique to split a given inclined vector in two perpendicular directions. Now, as an example, if I need to split this given F in these two perpendicular directions, this is how it is done. Always towards the angle. See, one component is coming towards the angle now, and this is only valid for acute angles. This is only valid for acute angles, right? And the component is a part. Component means part. So therefore, along this side, only a part of this force is going to come. Only a part. Towards the angle, that is called the cos component. Cos component means we are writing this as F cos theta. Cos component, F cos theta. Right? And the other component is going to be F sin theta, that is away from the angle. Towards the angle, cos component. Away from the angle, sin component. Right? The idea here is these two represents same F which was inclined by theta here. That is why I have put double-sided arrows. Right? The same force can be represented by these two perpendicular forces. Or these two forces can be represented by single inclined force like this. This is called dissolved components. Right? Now, as an example, whatever the thing that is done by these two simultaneously is done by this force single-handedly, alone. Is it clear? Which means, let's say this was a force of 10 newtons, and once I split it, I have got 6 newtons and 4 newtons like this. The idea is this 6 newtons and 4 newtons working together in these two directions, and it's going to be equivalent in terms of the result for this single inclined force. Right? This is a velocity. Right? Now, I'm explaining this using a force, and that is valid for any vector. Any vector that is valid. This is called dissolved components. Let me write that as well. This is called dissolved components. Dissolved. Dissolving means splitting. Dissolving in vectors means splitting. Dissolved components. Dissolved components means splitting into parts. ඒ කියන්නේ මේ force එකේ parts දෙකක් මට මේ විදිහට ලියන්න පුළුවන්. ඒතකොට ආයි මේක නෑ. මේක තමයි මේ parts දෙකකින් මම ලියලා තියෙන්නේ. Same force is represented by two perpendicular components like this. Right? That is called dissolved components. මේකෙන් මේක ගන්නත් පුළුවන්. මම ඊළඟට ඒක ගන්න විදිය කියලා දෙන්නම්. Right? And from here, the learning you should have is this. This is just for projectile motion, and all proofs of these dissolved components are under vectors, and you will be doing them under vectors. The proofs, right? Here the proof is not needed. This is the result of dissolved components. This is needed for our projectile motions because we are going to deal with inclined vectors. That's why, right? So from here, this is what just you have to know. If you are dissolving towards the angle, that is always the cos component. And if you are dissolving away from the angle, that is the sine component, right? And dissolving is only possible for acute angles. And always you will get two perpendicular vectors as dissolved components. Two perpendicular. Up to one directions in always we will be getting two perpendicular vectors. Right? Okay, first take this down, then I'll explain you the reverse as well. Reverse means make gannak puluva. Take this down as a note. Take this down as a note. You mean how it comes, is it? That will be proved under vectors, right? But here, if I explain how it comes, you won't understand because it is proved as by using a theorem called vector parallelogram theorem, right? Now, without knowing vector parallelogram theorem, we don't see this, right? That's the thing. So that's why I'm taking this down as a note because this is the part, this is needed for projectile motion and this is coming from vectors. We'll be proving that in our next lesson, vectors.
So you said something if force is this side, then that is sine.
If your angle is on the other side, that will be the cos component. Always towards the angle, cos. Towards. Towards क्यों हम एक direction कह रहे थे? Towards and away. Right? Towards the angle, cos. Away from the angle, sine. Right? That is called dissolved components. Which means this force can be represented by these two parts of these forces. These two components of the forces. Either one, both are equal, both are same, both are same. Now the reason is we can't use equations in inclined directions. No? We are going to use equations either vertically or horizontally. So that's why the requirement of dissolving in vertical and horizontal directions coming into consideration here, right?
Yeah.
It can be done only for acute angles, right? It should be acute. Don't think about the proof of dissolved components here under projectile motion because that's the thing that is what you are learning. You are going to learn soon, very soon under vectors. Vectors is our next coming up lesson, right? But this knowledge is needed here for projectile motion. Right? Okay. Mention here with a red pen. Mention here with a red pen. Dissolving into components. Dissolving into components. Dissolving into components. Dissolving into components. Dissolving into components can only be done with acute angles. 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 Right? Okay. You will understand this better when I explain this reverse process of this. Now write this as resultant of two perpendicular vectors. Resultant of two perpendicular vectors. Like this. Resultant of two perpendicular vectors. Resultant of two perpendicular vectors. Resultant means that's a single force or single vector to replace multiple vectors. Right? Now here I'm going to discuss about two perpendicular vectors. Resultant of two perpendicular vectors. Then if I have two vectors like this, I'm going to discuss about the resultant. Resultant in the sense the single vector that we can use to replace this. Right? Now in simple words, let's say you can sing. Right? You can sing. And you can, let's say, dance. Right? If there's another one who can let's say another one who can sing and dance. I mean, he can do both. Then that particular person is going to be the resultant of two of you. Is that clear? Clear? Let's say there's a particular person who can, let's say, who can bat, a batsman, and there's another person who can only bowl, who's a bowler. And if there is another one all-rounder that who can both bat and bowl, right? That's a resultant of the other two. So always resultant is the single vector to replace multiple vectors, right? Now here also, yes, single force to replace that combination. Components are multiple, can be two or more, and here in projectile motion we just need two, and in under vectors we will be discussing about more number of components, right? Now if I think of the resultant of two perpendicular vectors, now if I have splitted this single force into two perpendicular vectors like this, if I get the resultant of these two, again this should come. Is it clear? මේක split කළා මේක ආව නම් perpendicular මම දැන් මේ perpendicular දෙකේ resultant එක කියලා කියන්නේ single force එක ගත්තා නම් මේක එන්න ඕනේ, right? So resultant of look at here, resultant of two perpendicular vectors, now f sin theta and f cos theta is always acting in between, right? Always acting in between. So let's say this is R resultant, R, and resultant is given by, look at the board first, resultant is given by root x squared plus y squared. Let me write this like this to write the equation first, and then we will substitute. Look at here. So let's say I have two vectors as y and x. If vectors are y and x, the resultant is given by root x squared plus y squared, right? And these two vectors should be perpendicular to each other, resultant of two perpendicular vectors, right? Now if I use this to this previous case, look at here, R equals root, instead of x I have f cos theta, right? And that is f cos theta squared plus y is f sin theta whole thing squared, right? Which means this can be written as f squared from here cos squared theta plus this is f squared sin squared theta. In maths, we know, maths students should definitely know, right? We don't write this as sin theta squared, we don't write this as sin theta squared, we don't write this as sin theta squared because it's like theta squared. No, sin theta is going to be squared, so therefore sin theta whole thing squared is written as, this is wrong, this is written as sin squared theta, not sin theta squared. So that is what I have written here, right? Definitely math students should know, right? You know, you have done trigonometry by now, right? Not it? Haven't started? Starting next week. Don't know. You have bought. Right? So this is how it is written, no? Cos theta squared or sin theta squared is written as sin squared theta. මෙහෙම ලියන්නේ නැහැ. Right? ඒක තමයි ලියලා තියෙන්නේ. Now f squared is common, no? We can take it out. See, we can take it out. Now inside the root, if f squared is taken out, now sin squared theta plus cos squared theta remains, right? So this is a proved value. This is a proved value. Sin squared theta plus cos squared theta is 1. Sin squared theta plus cos squared theta is 1. That is proved, right? Mang angle legging on kala wenna. See, if you don't know that yet, sin squared the same angle plus cos squared the same angle will be 1 always for any angle, right? Let's consider 30 to show you this. See, then it should be sin squared 30 plus cos squared 30. No, මේක දන්නේ නැත්නම් බලාගන්න. Right? Sin squared 30 plus cos squared 30. What's the value of sin 30? Sin 30. I gave you the values last day, right? Yeah, last week I gave you the values. Now you should remember half. Right? Then this is half squared. And cos 30? root 3 over 2 squared, right? Then half squared is 1 over 4. Root 3 over 2 squared is 3 over 4. See, now this is 4 over 4 is 1. So likewise, for any angle, this is satisfied. For any kind of an angle, that is satisfied. So therefore, always sin squared theta plus cos squared theta equals 1. Right? Sin squared theta plus cos squared theta equals 1. So we can consider this as 1. That is 1. Since there is 1, see, now r equals root f squared, r equals root f squared, which means r equals f. Which means r equals f. Right? හරි මේ දෙක simplify කරාට පස්සේ ආයි f කියලා ආවා. That was the initial force. Right? And if we need to get the angle, this is how the angle is taken. Always we can write an angle using tan, because this side is going to be the opposite side, this side is going to be the adjacent side. So therefore this can be written as tan alpha using tan alpha. Tan alpha is opposite side is f sin theta. That is y over x. That is y over x. Now in my case, y is f sin alpha. F sin theta, sorry. And x is f cos theta. F to f cancels. Then tan alpha equals, we know sin over cos is tan. So tan alpha equals tan theta. Right? Hereafter we can remove tan from both sides, which means alpha equals theta. The same thing comes. Alpha equals theta, which means this can be replaced, this setup can be replaced with a single force of f with an angle theta. So that is what I have displayed before. Right? මේ දෙකේ opposite process දෙක තමයි මේ දෙක. If we are dissolving, we can dissolve a single force into two perpendicular vectors. And similarly, we can take the resultant of two perpendicular vectors like this. Right? We have to know both sides in the sense back and forth operations. Right? අපිට ඕන තැන් වල ඕන විදිහට මේක use කරන්න දෙකම තරම් ඉන්න ඕන. This is dissolving and the opposite action of dissolving is resultant. Finding the resultant. Right? Now take this down starting from here. And keep this in mind here onwards. Always sin squared theta plus cos squared theta is 1. Sin squared theta plus cos squared theta equals 1. Math students should know. Definitely math students should know. And after today, all of you should know, because we have that in physics. We have that in physics. So you can ask if you have any questions up to this point. And this total part is coming from vectors. That is why we are taking it down as a note. Right? Then after this note, again we will be moving back to the projectile things, projectile motion. Forward your questions if you have anything. Online students? Any questions? Is it all clear? All good? Root x squared plus y squared. No. X plus y whole thing squared is x squared plus 2xy plus y squared. Not x squared plus y squared.
The root doesn't have.
No, for additions you can't do it. Now, if needed, you can prove it with two numbers. You can say it with two numbers. Let's say, see. This is a good question. A student asked whether root x squared plus y squared can be written as x plus y, as x plus y. Right, x plus y. See, now if you have a doubt, you can use two real numbers and see whether it works. Right? This is wrong. I'll show you why that is wrong. See, let's take 3 and 4. Right? 3 and 4. Now you are saying 3 squared plus 4 squared root. Right? Now if I simplify this as look at here, 3 squared is 9, 4 squared is 16, right? And 9 plus 16 is 25. So that is going to be 5. Now if you do that, this will be 3 plus 4. That is going to be 7. Wrong. For additions, that is not good. Additions and subtractions. For multiplications and divisions, it's doable. Now if it was like x squared times y squared root, that is x dot y, xy, x dot y and xy. For additions, it's wrong. For additions, it's wrong. All good, sir. Good. Others? Now if you need, you can check it out using two numbers. Right? එහෙම හරියනවා නම් දැන් මෙයාගේ ස්ක්වයර් එක එන්න ඕනේ 5 කියලා. එහෙම වෙන්නේ නැහැ. That's wrong. Wrong mathematical application and a substitution. Any other questions? To understand this better, I'll give you an example with numbers. This is the concept here. This is the concept here. Right? To understand this better, I'll give you an example with numbers. Just wait a minute. We'll do an example with numbers. Students on YouTube, what about you? Is it clear? Is it all good? Is it all good up to this point? Clear, clear. All good. Okay. So let's move on. Let's see an example of this using numbers to understand this better. Right? Yes. Tan alpha. Tan is opposite side or adjacent side. The opposite side of this triangle is y. Adjacent side is x. You know tan alpha?
After cutting out that become tan theta.
Sino cosine tan. Right? Sino cosine tan. Right? See? We'll see an example with numbers. Look at the board. Let's say, look at here, let's say I have a velocity. Let's say I have a velocity, look at here, 100 ms minus 1, 30 degrees inclined to horizontal, right? 30 degrees inclined to horizontal, right? Now, if I dissolve this into components, look at here. If I need to dissolve this velocity is a vector, no? So that theory is valid for any vectors. So if I dissolve this into components. These are the two components I'm going to get. These are the two components I'm going to get. Towards the angle, that is 100 cos 30, right? Towards the angle, 100 cos 30. You can compare with the previous 100 cos 30. What is the value of cos 30? Root 3 over 2. So this is 50 root 3 newtons. Newtons ms minus 1. 50 root 3 ms minus 1. So which means horizontal component of this 100 is 50 root 3. Right? And vertical component is going to be, look at here, 100 sine 30. 100 sine 30. Sine 30 is half, which means 100 into half, 50 ms minus 1. Let me write here, that is 50 ms minus 1. 50 ms minus 1. Which means vertical component of this is 50 ms minus 1. Right? In other words, in meaningful words, the combination of 50 ms minus 1 in vertical direction and 50 root 3 ms minus 1 in horizontal direction is represented by 100 ms minus 1 in this direction. That's the idea. මේක split කළා මේ දෙක ගන්නත් පුළුවන්. මේ දෙක combine කළා මෙයාව ගන්නත් පුළුවන්. Either way it works only one na, only one. මෙයාව split කරොත් එන්නේ මේ දෙක. මේ split කරපු දෙන්නගෙන් resultant එක ගත්තොත් එන්නේ මේක. මම උන resultant එක අනිත් පැත්තට රම් පෙන්නන්න. Clear? This 100 of 30 degrees angle to horizontal can be represented by two velocities in perpendicular directions as 50 and 50 root 3. That's the meaning. 50 එකයි 50 root 3 එකයි මෙහෙම horizontal velocities දෙකේ resultant එක තමයි මේ 100 කියලා මැද්දෙන් ඇවිල්ලා තියෙන්නේ. So either 100 or these two. Both are same. Both are same.
So then
Right?
we add both should come again, right?
You can't add. If you are doing the resultant, you have to apply that resultant equation. That's why a resultant equation is there. Now if you apply to resultant equation, apply and see whether 100 is coming. Right? Clear? Now, if I need to get the resultant back, resultant is given by root x squared plus y squared. So, resultant is root x is 50 root 3 squared, 50 root 3 squared, y is 50 squared. Right? So, r equals root, this can be written as 50 squared times root 3 squared is 3, right? Plus this is 50 squared. What's the value of 50 squared? What's the value of 50 squared? 2500. 2500, right? 2500 times 3 is 7500. So this is 7500 plus 2500. 2500. And this is 10,000, right? 10,000 means this can be written as, if needed, this can be written as 10 to the power 4. So root of 10 to the power 4 is 10 squared, that is 100. So resultant of these two is 100 again, right? And if you need to get the angle, right? If you need to get the angle, let's say tan alpha is y over x, y here is 50, y here is 50, x is 50 root 3, 50 to 50 cancels. So tan alpha equals 1 over root 3, 1 over root 3, and alpha equals tan inverse 1 over root 3, right? 1 over root 3 is a non-tan value, that is respective tan 30. So therefore alpha is 30, right? Alpha is 30. So this is the back and forth processes, back and forth process we do, back and forth techniques we do to dissolve and take the resultant. Dissolving means we are splitting this into two, and resultant means again we are merging these two into the single resultant, single vector, right? So take this down as an example. Now this is an example with numbers. This is what we discussed. Likewise, any vector can be dissolved. Purpose to dissolve is, purpose behind dissolving is, when we are using equations, we will be using equations in horizontal and vertical directions, not in inclined directions. So therefore, if we are using horizontal and vertical directions, we have to have the vectors which are acting along horizontal and vertical directions. To find those vectors, we have to dissolve. Right? Take it down quickly. Stay vigilant in the lesson from the beginning, right? So if you stay from the beginning, this is not going to be a big deal. This is a very small and easy part, right? Very easy part. So be with the lesson from the beginning, right? Now we are doing projectile motion from the scratch. So if you grab everything, then you will solve any question from projectile motion easily, very easily, right? Don't get scared. Just understand from the beginning, and this is actually a part coming from vectors, but this is what we need for projectile motion. Since now we are going to deal with inclined vectors, because projectile motion is a non-linear motion, right? Now, that is why in linear motion we don't have a requirement to dissolve. That is anyway linear. If we have inclined vectors only, the requirement of dissolving into particular directions, perpendicular directions arises. That's why we have to dissolve. You can ask and get qualified if you have any questions, any other questions, any more questions. All good? Right. Now back to the lesson. Back to the lesson. Okay, write this down. Let's consider a particle. Let's consider a particle projected with let's consider a particle projected with initial velocity u with initial velocity u, an angle to horizontal theta, initial velocity u, an angle to horizontal theta, right? So before moving on to this, now here onwards we are going to see some applications, some approaches we do, some things we do in projectile motions. So before that, any questions up to this point, right? Now up to here, now I have discussed about the background of a projectile motion, and this is also a background thing we need for a projectile motion. First we introduce what a projectile motion is, and we identified that projectile motion consists of two linear motions happening at the same time, right? And then about dissolved components, right? Any questions or anything to clarify up to this point? What about you? Oh, good. Online students, Zoom and YouTube. What about you? Online students? Are you all on track up to this point? Clear. Okay, good. Can you explain tan alpha again? Tan alpha can be written as y over x. Now I wrote it in the previous one in the sense I haven't drawn the triangle here. In this part, right? This is the example now. So before the example, I draw the triangle. Now from that triangle, opposite side is going to be a y axis. Opposite side is going to be y-axis, and adjacent side is going to be an x-axis. So that is why tan alpha is always y over x. Now corresponding y here is 50. Corresponding x here is 50 root 3. Right? Then 50 over 50 root 3, 50 cancels. Tan alpha becomes 1 over root 3. Then alpha is tan inverse 1 over root 3. Tan inverse 1 over root 3. Right? So tan 30 is 1 over root 3. No? So therefore, tan inverse 1 over root 3 is 30. Tan 30 is 1 over root 3. We discussed under linear motion. Tan 30 is 1 over root 3. So tan inverse 1 over root 3 is 30. So alpha is 30. Is it clear now? Yes. Others? Clear? Okay. Okay. Look at here. Now I'm going to consider a projection which is projected with u. Look at here with initial velocity u. Initial velocity u. Initial velocity u. Initial velocity u. An angle of projection theta. Something like this. Right? Horizontal angle theta. Now if I plot the path, this path is going to be like this. Path of this motion is going to be something like this. Right? And this is my starting point. Let's say A, B, C again, and maximum point B, and final point C. And this is T equals 0 of the motion, and this is T equals T, last point of the motion. Right? Okay. Now, first take this down. Take this down. Now we are going to identify some parts, identify and find actually. Find some things regarding this projectile motion. Now, as an example, maximum height and time taken to projectile motion, about velocities and about the horizontal distance it traveled. So likewise, now we are going to find different things regarding this projectile motion. Different things regarding this projectile motion, the projection. Right. So this is the given velocity. This is the given velocity u. This is the given velocity u. So any projectile motion travels under gravity. So therefore, gravitational acceleration is here. Throughout the motion, we have gravitational acceleration. I'm marking it here. Right. Throughout the motion, at any point of this motion, it has the gravitational acceleration because it's a motion under gravity. It's a motion under gravity. It's a motion under gravity. Right? Okay. Now we are going to deal with this inclined velocity now. Right? So that is where the dissolved components coming into play. Right? Now dissolve this given u into perpendicular directions and mark its components. First mark by your own before I mark. Dissolve this u and mark its components. Right? If the angle is measured in the horizontal direction and the other direction is going to be the vertical direction, because always we can dissolve only along two perpendicular directions only. Right? Only along two perpendicular directions. Dissolve it. Dissolve. Finish. Towards the angle, this is going to be u cos theta. away from the angle, this is going to be u sine theta. So likewise, we can dissolve it, right? Towards the angle, cos component u cos theta, and away from the angle, sine component u sine theta. Away from the angle u sine theta. Right? Okay, now here onwards, hereafter, what we are going to do is we are going to find out some things, some important parameters like time, maximum height, range, likewise some important parameters about this projectile motion, and where we will see how we are going to approach these things, right? So let's go one by one. As row number one, write down row number one. As row number one, write down what's the maximum height. As row number one, write down what's the maximum height. What's the maximum height? We are going to find them out one by one. This is row number one. What's the maximum height? What's the maximum height reached by the particle? What's the maximum height reached by the particle? What's the maximum height reached by the particle? Right. Now, from this diagram, we can see the maximum height now. If it travels from here to here, right? Maximum height reached by the particle is here, which means this is what we are going to determine. This one, right? Is it clear? Mark it as H. That's the maximum height of the particle. No? Maximum height measured from ground. Now this is a ground. This is a ground. Maximum height of the particle is here. This height. This height. Right? Now, when it comes to solving about this, always we are thinking of two linear motions, right? So that is why we found out that any projectile motion is a combination of two linear motions, right? Whatever it is asked from you, we will be aligning it with two linear motions, and we are going to solve, because we don't have any new equations or special equations for a projectile motion. What we know is only for linear motion. Now tell me, if I'm thinking of this maximum height, is this maximum height involves with the vertical linear motion or horizontal linear motion? Vertical linear motion, right? And maximum height of that particular vertical linear motion is exactly equivalent to the maximum height of the projectile motion. Is that clear? Then as this side, if I can consider the vertical linear motion, and if I can find out the maximum height of that vertical linear motion, that will be same as this, no? That is what our approach is. Right? Now, from A to B, we are going to use, look at here, from A to B, this is my section. From A to B, vertically upwards, we are going to use a linear motion equation now, because we know linear motion goes from A to B to B to A, back and forth, right? Upwards and downwards. Now, from A to B, if I consider the vertical linear motion, maximum height of that vertical linear motion will be the maximum height of the projection. You know how to determine maximum height of a linear motion that we have discussed, right? 2-3 weeks before. I mean, from the very starting day also we discussed, right? Now, if this is not moving upwards further, which means vertical velocity component here is 0, right? Same idea. In a vertical linear motion, I'm comparing this with this. See, look at here. If you need to recall, let's say this is projected with you, and this undergoes a linear motion like this. Right? And maximum velocity reached by this linear motion is, let's say, h, right? And at the maximum point, velocity of this motion is 0, right? So likewise, by considering this motion from here to here, you determine the maximum height of this linear motion. I'm going to do the same here. Now, from A to B, vertically upwards, I'm going to use a linear motion equation. Now, the time is unknown yet, no? Since time is unknown, use v squared equals u squared plus 2as, right? Now, when I'm using the equation vertically, we have to consider all the vertical components because considered direction is now vertical. If I have inclined vectors for considered direction, third vector rule, we have to dissolve them into components. Now I have two components here. One is vertical, one is horizontal. Now horizontal one is going to be perpendicular. So therefore that will be neglected, but vertical one will be considered. Right? Now if I have done dissolving, which means this u is not anymore to either single u or these two. That is what dissolving means. If we have done dissolving, which means u is not here anymore. We have these two now. Right? V squared is the velocity here. Velocity upwards, upwards velocity, upwards final velocity here, 0. 0 squared is 0. U is initial velocity of this section that is at A. Initial velocity of the section is not u cos theta, that is u sin theta. Right? Initial linear velocity in this direction, upward direction, is u sin theta. Vertically upwards I am considering, and this velocity is also vertically upwards, that is plus, so that is u sin theta. It should be u sin theta whole thing square, right? Plus 2. I'm using the equation upwards. Gx downwards, that will be minus g. That will be minus g. And vertical height is h. Right? Now, if we simplify this, we will get h. If we simplify this, we will get h. So that's why I was saying continuously from the beginning that this is actually an extension of linear motion. Right? We are using linear motion equations. Everything is from linear motion. And the difference is now we have two linear motions happening at the same time, simultaneously. Two linear motions. Right? This is very much similar to what you are doing here. Very much similar. Right? Very much similar. Solve this. Minus 2gh can be written as 2gh on the other side. 2gh is, don't substitute g because we are dealing with labels. Sin squared theta. If values are given as numbers, then you can substitute g as 10 and get the numerical value. Now h is u squared sin squared theta over 2g. So maximum height reached by the particle is this now. U squared sin squared theta over 2g. That is the maximum height reached by this particle. Right? So simply what we are doing is, if we are asked about something, right, you have to understand whether it's relevant to the vertical linear motion or horizontal linear motion, right? And you have to pick the correct one, suitable one, and apply a linear motion equation to get it done. ඔච්චරයි කරන්න තියෙන්නේ. මේක දිහා බැලුවා, අහලා තියෙන එක කෙලින් බැලුවා vertical linear motion එකේ කෑල්ලක්ද horizontal linear motion එකේ කෑල්ලක්ද කියලා. හරි? අන්න ඒකට හරියන්න linear motion equation එකක් දැම්මා. So even though the actual object travels in a parabolic path, we are considering its linear motions and solving the question. Is it clear? Ask your questions. Clear? Online students? Questions? Clear? Understood. Good, good. Very good. Others? What about you on YouTube? Are you with me up to this point? Yes. Good. Okay. Okay. Mention this with red pen. So I'll give you the explanation for each of these parts in red, right? So when you go through this again, just see what is written in red. Then you will understand it again. I mean, if you forgot what we have done here, just go through what I have written in red, right? There I'll explain what we have done here with the logic, with the argument. Write down in red. When projection travels from when projection travels from when projection travels from when projection travels from A to B, when projection travels from A to B along parabola, A to B along parabola, put a comma, along parabola, maximum height it reached, maximum height it reached is the vertical displacement between 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 points A and B. It's a vertical displacement between points A and B. Next point. Therefore, by considering vertical motion, therefore, by considering vertical motion of particle from A to B, therefore, by considering vertical motion of particle from A to B, vertical motion of particle from A to B, maximum height reached by projection can be determined. 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 Right? Understood, right? You can see the board, right? See the board now? Right. Okay, let's move on. As the ROM number 2, write down. ROM number 2, next question. ROM number 2, write down. What's the time taken? What's the time taken by particle 2? ROM number 2, write down. ROM number 2. What's the time taken by particle 2? What's the time taken by particle 2? ROM number 2. What's the time taken by particle 2? What's the time taken by particle to reach maximum point? What's the time taken by particle to reach maximum point? What's the time taken by particle to reach maximum point? What's the time taken by particle to reach maximum point? Right. Now tell me. Now I need the time from A to B. Yeah? Let's say TAB. Now for my time from A to B is TAB. We need TAB. Time from A to B. Right? Tell me, when we think of time, is it involves with the vertical motion or horizontal motion or both? Is it same or different for vertical and horizontal motions? Same. Online students, what about the time from A to B? Is it same for vertical motion and same for horizontal motion, or is it different? Right? Now, if you listen to the previous explanation, I explained using projections, right? Answering this question is very straightforward and very much easy. Very much easy, very easy. What's your thought? What's your thought? Same or different? Right? So both starts at the same time now, and both ends at the same time. So always these two motions are simultaneous. I told you, simultaneous, which means same time. So doesn't matter in which motion it is, time is same. Time is same. Right? Now I need the time from A to B. Right? Okay. What we can do? Any suggestions? Now I need to find out the time from A to B. Now think of one of the linear motions that is applicable to here and tell me what we can do to find out the time. Now think by your own. Before I explain, now think by your own. Think by your own before I explain. What can you say?
Equals plus 80.
First tell me the motion. You are going to consider vertical motion, no horizontal motion? Horizontal. Equation V equals u plus at. What about final velocity? Horizontal final velocity? Not yet known. Right? Only vertical velocity is known. Any other suggestions? V equals u plus at vertically. That's possible. That's possible. Right? Good. That's possible. Because initial vertical velocity is known. Final vertical velocity is also known. Right? Acceleration is anyway known, which means t can be determined. Yes? Yes. So what we can do is, see, that is correct. That is correct. Now, if I need time, even though time is same for both horizontal and vertical motions, I don't have enough data to deal with the horizontal motion yet. Final velocities, horizontal displacements are unknown. Right? Final velocities in the sense final horizontal velocities. Always we have to stick to the considered direction. That is how we deal with a vector. Right? We started this discussion way back from linear motion about vectors and basic rules regarding vectors. Always we have to stick to a considered direction. And vectors which are acting to the same direction of consideration will be plus, opposite will be minus. Inclined vectors are dissolved into components. So that is what we did here, since there is an inclined vector. And if I have perpendicular vectors, they will be neglected. Right? හතරයි තියෙන්නේ. ඒතර vectors එක deal කරද්දී ඔය හතර විතරයි තියෙන්නේ. වෙන මොකුත් නැහැ. Even though you are moving forward in this syllabus and even in maths, only 4 vector rules are, basic rules are these 4. හරි. ඒ හතර මතකයි නම් ඒ හතරෙන් තමයි ඕනම එකකට apply කරන්නේ. Right? Okay. Now from A to B, if I need this, my section is this. See? From A to B, from A to B, direction is vertically upwards. V equals u plus at. V equals u plus at. Right. Apply this and find out the time. Final velocity is the velocity at B. Final vertical velocity at B is 0, known. And initial velocity is the velocity at A. I'm applying from A to B. So initial velocity is the velocity at A. Initial velocity at A is vertically u sine theta. So that is u sine theta. Plus, now applying vertically upwards, G is vertically downwards, opposite to direction of consideration. So G is minus G. And time is TAB. Right? Minus GTAB can be written as GTAB on left hand side, the other side equals u sine theta. So what I needed was TAB. TAB equals u sine theta over G. TAB is u sine theta over G. TAB is u sine theta over G. Which means time taken to travel from A to B is u sine theta over G. Forward your questions if you have anything to know. Forward your questions if you have anything to know. If you need any clarifications, any kind of clarifications, any doubts you have, forward your questions. Is it clear? All good? Online one? Now, here we are starting the discussion on basics of projectile motion. So one by one, we are determining these basics, right? Determining vertical height, about times, velocities, horizontal distances, displacements. We will be determining one by one. Clear? Okay. Okay. Mention this in red. Below this, mention this with red. Mention this with red. Below this, mention this with red. Time takes from A to B. Time takes from A to B. Time takes from A to B in vertical motion. In vertical motion, and horizontal motion are same. Are same. Are same. Right? Okay. Moving on. Moving on. From number 3. From number 3. From number 3. Write down. Write down. Determine. 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 Total flying time. Total flying time. Total flying time of this particle. Determine total flying time of this particle. Determine total flying time of this particle. Total flying time of this particle. Flying time is this, right? We call this a flight. This is a flight from A to C. That is a flight, right? It travels under gravity, no? So this is a flight, and the time taken from start to the end is called the flying time, right? Flying time. Flying time is actually the total time it takes to reach ground again, and flying time is always the total time in air. Total time in air starts from here and travels in air and reaching the ground again. So total time in air is the flying time, right? Okay. Think of something and try something. I'll give you 2 minutes. Think of something and try it. Think of something and try it. What we can do to determine total flying time. And if you got any answers, you can tell me the answers, and online students, you can put them to the chat box. Try to get it by applying an equation. Try to get it by applying an equation. So think of a suitable equation and apply, and try to get it by applying an equation. And the ones who have any doubts, you can ask your questions. The ones who have doubts, you can ask your questions. Right? You're from Zahir College? You?
He does.
You came to Archimedes theorem seminar? Theorem? Shit. ठीक है. Mention the direction and section. Mention direction and section. That's a must. That's a must. And you can think of what we did in linear motion as well to determine total time. We want to do it after 6, shall I? Okay, that's fine, that's fine. That's fine. Online students, any answers? Online students, any answers? විශාසනා කිව්ව ඉඳ කට්ටිය බය වෙලා දින්නේ නැහැ. A-levels are getting closer day by day. This year also now 25 batch is only 17 weeks ahead of the exam. Right? Now they are like working around 12 to 15 hours a day. A single student average, right, works around 12 to 15 hours a day. And there are some students whom I know personally, they work around 18 hours a day. Likewise, there is no limit when it comes to studying and working here, right? So whatever we do and what's the effort we put, right, will be mirrored to us, will be reflected to us as results, right? That is how it happens. Below root 2gh over g. No, check again. There should be components coming. There should be sine or cos components coming. Definitely components are coming, right? Not just a mere g, a single g, right? So likewise, now when it comes to u, now in this period, actually, to be honest, if you are working, let's say 1 hour a day, 1 hour a day, right? I'm not saying about the class times, right? For your own things, for your own studies, let's say you are spending 1 hour a day, 1 hour is also enough in this stage. So likewise, it should be increased. Now when it comes to 26 batch, now average student works around 6 to 7 hours a day, 26 batch students, right? So likewise, it should be improved. නැත්නම් එකපාරට exam ලඟ වෙලා එකපාරට 12 hours වැඩ කරන්න හිතුවා කියලා එහෙම කරන්නත් බෑ, because your body is not ready for it, right? We have to gradually increase that and reach there, right? So always, now at this stage, allocate a 1 hour time per day. Yeah, it's like 7 hours a week per day. Allocate 1 hour for your own studies, right? And you can divide it between among subjects and manage that time. And after another 2-3 months, I'll ask you to increase that to 2 hours. So likewise, bit by bit, we have to improve. And now, to be honest, personally, I know there are some students who are working 18 hours a day, right? Still, they are having all meals, getting a bath, having a bath, and doing all the things as well during the remaining 6 hours of the day, right? Without just washing the face and everything, ඒගොල්ලෝ නිකන් වැඩ කරන්න එහෙම නෙමෙයි. අනිත් දේවලුත් manage කරගෙන 18 hours වැඩ කරනවා class නැති දවස්වලට. එහෙම ළමයි ඉන්නවා. That's the level you have to improve, right? Example එකත් ඒක කියන්න. That's the level you have to improve ultimately, right? So therefore, know where we are going to head, where we are heading in this journey, right? කොහොමද average student කෙනෙක් ගත්තාම මේ දවස්වල 25 students ලාගේ කොහොමත් 16 hours විතර average ඒගොල්ලන්ගේ වැටෙනවා 15 16 ඔය වගේ average යනවා, right? That's the level. Yeah, what's the answer? No. That's same as this, no? This is the time for a half, then it cannot be the total time. Correct. That is correct, but I asked you to apply an equation and get it, right? Because we are going to prove this. Now, after proof, we can use it as well, you can use it as well, but now try getting it using an equation. And the hint is, we did the same thing under linear motion. 2v sin theta og. 2u saying 2u sin theta og. It's correct. Good. Yeah, it's correct. Good. Now, if I need to get this time, now there are two possible methods. I'll explain both. Look at here. There are two possible methods. Method 1. Look at here. Method 1. Now, since I already know the time from A to B, if I find out the time from B to C, right? We can add these two and get the total time now. Is it clear? Now, from the previous step, I know the time from A to B already, right? Which means by using another equation, if I can get the time from B to C of the motion, right? Which means by adding those two also, I can come up with the total time. That is one method. So first thing, as the first method, I'm going to do that. My first target is determining time from B to C. To determine time from B to C, I'm going to use an equation from B to C. See, from B to C, downwards, because the motion is also downwards now. Downwards, I'm going to use an equation like S equals ut plus half AD squared. Because final velocities are unknown, I don't know the velocities at C yet. That is not 0. Velocity at C is not 0. Once the projection is hitting with the ground, that is not smoothly hitting with the ground. No, it hits with the ground. It collides. So there's a velocity there. We don't know the velocity yet. So therefore, I'm going to go with this. From B to C, no, then S should be the vertical height from B to C. That is equivalent to H. That is H. That is same as H. And U is the initial velocity at B. That is 0. 0 into T is 0. Plus half. Now applying downwards, G is also downwards. Plus G. T is TBC squared. Now H is a known value. H is known from here. See, I'm going to plug that. H is known from here. Because H is not given. But H is U squared sin squared theta over 2G equals, from this side I have half GTBC squared. Right? We can simplify this. This 2 cancels. 2 to 2 cancels, right? 2 to 2 cancels. And TBC squared can be subjected. TBC squared can be subjected. That will be u squared sine squared theta over g and g squared. Right? G times g squared. So this can be written as TBC squared can be written as, for multiplications we can take the square out. This can be written as this. This is possible for multiplications, not for additions. Right? Now, if I need TBC, take the square root. Square root of this is u sine theta over g. U sine theta over g. Which means TBC is also known now. Which means TBC is also known. If that is known, therefore, look at here, total flying time. Therefore, total flying time, let's say TAC, A to C, right? So TAC can be written as TAB plus TBC. TAB plus TBC, right? TAB is here. U sine theta over G plus TBC is here. That is also same. U sine theta over G, which means TAC equals 2U sine theta over G, which means TAC is 2U sine theta over G. So final answer is 2U sine theta over G. 2U sine theta over G, and this is method 1. I'll explain another method 2 as well. This is method 1, right? Determining the time for first half. This is called the first half, and this is called the second half of the motion. And determine the time for second half separately, and merging them together. Clear? Take it down. Take it down. So this is method 1. I'll explain another method. First, take this down. Now, from this, there is a learning that we can take out, that is, time taken for first half of the motion is equal to time taken for second half of the motion. This only happens if the motion is symmetric. If there is an asymmetric motion of projection, that is definitely different. Now, as an example, if I release this object from here and going to let this fall to the ground, now the motion is asymmetric. In such cases, times are different. But if the motion is symmetric, times are same. Symmetric in the sense, the particle should reach back to the same level it starts. If not, times are also different. Finished. And method 2 is this. I'll do it here. See, method 2. You got the same experience. In linear motion. We did this to find out the total time in a linear motion, right? Now again, I'm going to use a linear motion equation from A to C, vertically upwards, an equation like s equals ut plus half at squared. We did the same in linear motion. Tell me, what's the vertical displacement from A to C? What's the vertical displacement from A to C of this object? H. Others? What's the vertical displacement of this object from A to C? We got the same experience in linear motion. What's the vertical displacement from A to C of this object? You? 2h. Others? Online students? Online? H. Others? Quickly. Vertical displacement. Vertical displacement is 0. We got the same experience in linear motion. Vertical displacement is 0. Vertical distance is 2h. Vertical displacement is 0. Right? There is no vertical height difference between A and C. Vertical displacement is 0. Right? 0. Not a new thing. Not a new thing, because we did the same in linear motion to find out the total time. Right? Now, if you can't remember, please go back to linear motion and see what we have done there. Right? So, as I told you, weekly, you have to attend to those things. Attend to those things weekly. Otherwise, if you miss 1 week, then 2 weeks, then you are going to pile up everything and end up struggling. Right? And u is the velocity at A, vertically, u sine theta only. U sine theta. Right? T, now the time is TAC plus half. Applying the equation vertically upwards, G is vertically downwards, so minus G, and this time is TAC squared. Take this to the other side. This will be half G TAC squared, and this is U sine theta TAC. One TAC to one TAC cancelled. Subject TAC from here, multiplication, 2u sine theta over G. 2u sine theta over G. So straight away at once we are getting this. Questions? 2h. No. 0. So refer the things we have done in linear motion. Right? So from the start, that's why I told you that. That's why I keep telling you that this is an extension of linear motion. This is an extension of linear motion. An extension of linear motion. Right? We did this same thing in linear motion. Right? So we didn't have any angles. So you got 2u over G in linear motion without any angles. Right? Take it down. And this is the quickest and shortest method. So put some asterisk marks if needed. This is the shortest method and the easiest method. Shortest in the sense easiest. That's the easiest method to determine total flying time of the particle. Easiest. That's the easiest method to determine total flying time of the particle. This is method 2. Haven't I mentioned it? Here mention it. This is my method 2. This is method 2. This is method 2. Method 1 is this by the sum, by the addition of these 2 times, and method 1 is that method 2 is directly straight line s equals ut plus half a squared upwards, and at once we will get 2 sin theta over G. Same answer. Same answer. Yeah. Right? Mention this in red. Mention this in red after the question. Mention this in red. vertical displacement from vertical displacement from A to C is 0. 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 Second point, times taken. Second point, times taken to complete times taken to complete first half of the motion is equal to time taken to complete second half of the motion in a symmetric projectile motion. Symmetric. It must be symmetric to satisfy that. It must be symmetric to satisfy that. There are asymmetric projectile motions, right? We will see such questions in the coming up parts. There are asymmetric projectile motions, right? If the object starts from somewhere and ends up somewhere at a different level, not coming back to the same level, right? So if that is symmetric only, these two times are going to be equal. This is valid for any case. This is valid for any kind of a projectile motion, right? Okay. So before moving on to part 4, I'll give you 5 minutes to pray. Quickly pray and come. Why don't we consider the positive aspect of G when the object is falling? I have considered the positive aspect of G. When I use the equation downwards, G is positive. When I use an equation upwards, G is negative, right? Positive G comes if my considered direction is downwards. Negative G minus G comes if my considered direction is upwards, right? Is it clear, Zaid? Come back in 5 minutes. It's 6:05. I'll be starting at 6:10. Yeah, okay, good. Ask it from the other side, the other classroom. And in the online class also, since there are Muslim students, right? So you can quickly go back and go and pray and come back to the class. I'm giving you 5 minutes to pray. 5 minutes up, not a much time, just 5 minutes. So quickly pray and come to the class if needed, right? I'm starting at 6:10. I'm starting at 6:10. But in the second one, there's the part in which G is positive, right? No. Positivity and negativity of G changes with my considered direction, right? Positivity of G is with the considered direction. Now, for method 2, considered direction is upwards. I'm considering upward direction all the way from A to C. Then throughout G is minus. Throughout G is minus. So always that is with the considered direction. Otherwise, there are no defined directions as positive and negative. That is with respect to your considered direction. If you are considering upwards, then accordingly vectors changes. Vectors change. And if you are considering downwards, according to that, the signs of vectors change. That is how it goes. Done? Any other questions? I hope it's clear now, but still, if you got any questions, Zaid, you can keep asking questions and clarify it. Right? Consider direction is always with the direction of consideration, the positivity and negativity of a vector. Positivity and negativity of a vector is always with respect to direction of consideration. That is with respect to direction of consideration. Clear now? Okay, good. Okay, back to the lesson. Part 4. Will it take much time? Will it take much time for the other one?
Oh,
The other one?
yeah,
The one?
yeah.
Now it's coming. Right, part 4. Part 4. First write down. Part 4. What's the horizontal range? What's the horizontal range of above particle? 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 Part 4. Horizontal range. Horizontal range of a projectile motion is the horizontal distance from A to C. Horizontal distance from A to C is called the horizontal range. Horizontal range of projectile motion. And usually we denote it by R, like this. Mark R. With the meaning of range, we denote it by R. Horizontal range. We denote it by R. Horizontal range of a particle. Horizontal range of a particle. Right? Okay. I'll give you 2 minutes again. Think of an equation, select an equation with a section and apply it and try to find horizontal range. And try to find the horizontal range. I'll give you 2 minutes. Find the horizontal range, and if you got any answers, you can save your answers. You can save your answers, and online students, you can put them to the chat box. Write part 4 and try it. I'll give you 2 minutes. We'll give you 2 minutes to try part 4. We'll give you 2 minutes to try part 4. Part 4. And online students, you also can send your answers to the chat box if you got answers. Horizontal range. Horizontal range of a projection is from A to C. Yeah? Horizontal range is the horizontal distance traveled by the projection. That is called the horizontal range. Right? Now there are likewise there are technical terms, so special jargon when it comes to projectile motions. Right? Horizontal range of projectile motion is this. Flying time is the rotor time. Maximum height is. It makes sense. No? So likewise, different technical terms are also there. Horizontal range is the horizontal distance traveled. Now in this case, there is a distance from A to C. We denote it by R with the meaning of range. With the meaning of range. So think of it and do something and determine R. Determine R. Do something and determine R. Think and do something to determine R. Any answers? Any answers? Use sine squared theta over G. No. Check again. Check again. It's good that you tried. Check again. Delusion. Check again. Others? Okay, let's see. Any other answers before starting? No?
Solve.
Have to solve. Okay. Keep trying. Keep trying. I need the horizontal distance from A to C. No? So first tell me whether it's involves with the horizontal linear motion or vertical linear motion. Horizontal linear motion. Then to get the distance from A to C, I have to use an equation from A to C. From A to C, right? Horizontally. Horizontally. Any suggestions for the equation? What are the equations we can use? S equals UD plus half AD squared, right? S equals UD plus half AD squared, correct, right? S from A to C is R range, and U is U cos theta, because I'm using the equation horizontally. Horizontal component here at A, initial horizontal component is not U, that is U cos theta. Then U cos theta T, right? And T is actually the time taken from A to C, TAC plus half. What about A? What about A? Plus G or minus G? Minus G. Plus G. It's 0 because I'm using horizontally. G is acting vertically. G is acting vertically. So it's neglected. It's neglected. It's 0. And 0 into TAC squared again. Right? 0 times anything is 0. So this whole part becomes 0. This whole part becomes 0. Right? My considered direction is repeating again. This is important. This is perpendicular to. B is now perpendicular to considered direction. Perpendicular to considered direction. If it is perpendicular, it should be neglected. Now it is neglected. Neglecting means there is no acceleration horizontally now. There is no horizontal acceleration. So simplify this. R equals U cos theta times TAC. TAC is here. TAC is 2U sin theta over G. So R is 2U times U is U squared sin theta cos theta over G. This is the horizontal range of the particle. This is the horizontal range of the particle. U squared sin theta cos theta over G. Yeah, good. Now it's correct. Now it's correct. It's correct. Understood? Right? There is another way to write this. We have something called half angle expansions in trigonometry, right? Math students will definitely learn very soon. And half angle expansions of sine theta is also needed for A-level physics, right? So therefore, with that, now learn this here. This answer can be written this way as well. There is an expansion for sine 2 theta. Sine 2 theta can be written as 2 sine theta cos theta. This is called half angle expansions, right? Sine 2 theta can be written as 2 sine theta cos theta. And there are other half angle expansions for cos tan as well. But for physics, only sine half angle expansions are needed. So sine 2 theta can be written as 2 sine theta cos theta. So if needed, we can include sine 2 theta into this, right? So if there's anyone who doesn't know this, I will prove this and show using an angle. Let's take an angle like 60, right? Now according to this, sine 60 can be written as 2 sine 30 if 2 theta comes, right? So half of the angle. Sine 60 can be written as 2 sine 30 cos 30, right? So we can check whether it works. What's the value of sine 60? What's the value of sine 60? Root 3 over 2, right? Now if I simplify this side, 2 times sine 30 is half, cos 30 is root 3 over 2. 2 to 2 cancels. See, root 3 over 2 comes again, right? This is valid for any angle. This is a sine half angle expansion. Sin 2 theta can be written as 2 sin theta cos theta. Can you repeat the fourth question? Can you repeat the fourth question? What are you? Determine the horizontal range of the particle. Fourth question is determine horizontal range of the particle. Determine horizontal range of the particle. Right? Now this is the proof. Now I'll use this result. Now wherever I have 2 sin theta cos theta, we can write it as sin 2 theta. Now here, see this R is, now if I take this together, 2 sin theta cos theta times u squared over g, no? Same thing. And this is sin 2 theta. So therefore this can be written as u squared sin 2 theta over g. Right? Both are correct. Both are correct. This is something additional I wanted to show you. Otherwise, these expansions are coming in optics for physics, right? But here you can learn it because when it comes to some projectile motion questions, angles like 15 is given most of the times. That is because we can make it 2 theta and make it 30. Otherwise, we don't know the values of 15. No? When this is 2 theta, it will become 30. Sin 30 is known. So likewise, questions are coming, right? So therefore, take this down as well quickly. Finished. This is something coming from trigonometry. Okay, mention this with a red pen. Mention this with a red pen. Mention this with a red pen. G is neglected. G is neglected. G is neglected when equation is applied horizontally. G is neglected when equation is applied horizontally. G is neglected when equation is applied horizontally. Since direction of consideration, since direction of consideration is perpendicular to since direction of consideration is perpendicular to direction of g is perpendicular to direction of g. Right? Part 5. Write down part 5. Determine horizontal velocities at points B and C. 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 Give it a try. I need the horizontal velocities at B and C. Now, when we think of vertical and horizontal motions, now always we can write velocity at any point using a vertical velocity component and a horizontal velocity component, right? So let's assume horizontal velocity at B as VB. You can mark along with me, and horizontal velocity at C as VC. Now what I asked you to do is find VB and VC quickly. Do something and determine VB and VC. Do something and determine VB and VC. Do something and determine VB and VC. Any answers? Sorry? Online? Online students? Any answers? What about the ones on YouTube? Any answers you got? Okay. See what you can do. What you can do. If I need the velocity at B, right? That's a horizontal velocity now. Then that involves with the horizontal motion. Horizontal motion. I'm going to use an equation like V equals U plus AD from A to B. See, from A to B horizontally, V equals U plus AD. Then V is the velocity at the last final point VB, and U is the velocity here at the initial point A, that is U cos theta, horizontal component. I'm using the equation horizontally. G is acting vertically, so it is neglected 0. 0 into T. 0 into anything is 0. So VB is U cos theta. VB is U cos theta. Right? Clear? VB is U cos theta. No impact from G when I use the equation horizontally, because G is always acting vertical, in the vertical direction. Right? So that's the direction perpendicular to the direction of consideration. It's neglected. So easiest way to get that is V equals U plus AD. Easiest way is V equals U plus AD. Similarly, you can find out the velocity at C as well. Use any 2 points. Now I'll be using B to C. From B to C, keep it silent. V equals U plus AD. From B to C, then at B, at C, the final velocity is Vc, right? At C, and initial velocity it should be at B horizontally, that is Vb. Plus still G is perpendicular, so it is neglected. Vc equals Vb. Vb is here U cos theta. So if needed, you can apply from A to C as well, as you prefer. Right? You can apply from A to C as well. That is fine. As you prefer, you can apply. Right? So from this, we have another takeout. We have a takeout learning. That is, now since G is always vertical, G cannot impact on horizontal velocities. Because to change a horizontal velocity, there should be a horizontal acceleration. But here, there is no horizontal acceleration. Therefore, horizontal velocity component of any projectile motion remains unchanged, constant. Right? That's the learning we have. Take it down quickly and write down in red. Horizontal velocity component of a projectile motion. Horizontal velocity component of a projectile motion remains constant. Since there is no horizontal acceleration, throughout the motion. Right? Part 6. Part 6. Write down. Determine direction and magnitude. Determine direction and magnitude. Determine direction and magnitude of velocity of particle at c. Of velocity of particle at c. Determine direction and magnitude of velocity of particle at c. Right? Now at c, horizontal component is known by now. Definitely there's a vertical component as well. Right? So I'll mark this vertical component as y. So first determine y. If y is known, the velocity is going to be the resultant of these two. Velocity means that's a net velocity, the resultant velocity. If you asked about horizontal velocity or vertical velocity separately, then you should answer as vertical or horizontal. Now, if you asked about velocity means that's the actual velocity. Actual velocity is the single velocity component. That's the resultant velocity. Y හොයාගත්තා මේක perpendicular. Perpendicular දෙන්නෙක්ගේ resultant එක ලියන්න අපි දන්නවනේ. As root x squared plus y squared. එහෙනම් y හොයාගත්තා නම් ගාන ඉවරයි. Determine y quickly. Determine y. I introduce it as y. We have to find y. Vertical velocity here. Vertical velocity. Vertical velocity. You can label it using any term, that's fine, as v1, v2, v3, anything. I labeled as y. Vertical velocity component. For sure, we know the direction is downwards because the motion is from motion from B to C is downwards motion. No? So therefore, definitely this velocity is downwards, right? Then it should be vertically downwards. So likewise, we can mark it as a vertically downward velocity. In first half, for sure, that is upwards. In the second half, vertical velocity is downwards, right? Determine y. Determine y. No, direction of the component is known, but direction of the actual velocity is unknown. Direction of velocity is direction of the resultant. Resultant is something acting in between, no? The direction of that is direction of that resultant. We have to find it out. First determine the value y. What you can do? Apply an equation from B to C. There are different methods. I'm using from B to C. Right? There are multiple methods. Huh? As long as your application is a proper application, a correct application, you will get the same answer. From B to C, vertical downwards, I'm going to use what I can use? V equals U plus 80. V equals U plus 80. Right? Vertical velocity component at C is y. Now V is y. U is the vertical velocity component at B. That is 0. That we know. Plus G, T. T is TBC. TBC was determined before. That was U sin theta over G. Right? So these two cancels. Y is U sin theta. Y equals U sin theta. Right? Y equals U sin theta again. Now the resultant or the net velocity, resultant velocity is acting in between. Right? So let's say this resultant velocity as, let's say the resultant velocity as R dash. R dash. We can write R dash as root x squared plus y squared. No? So R dash equals x squared. X squared is, now the x direction is this horizontal direction, VC. VC is known. So x is U cos theta squared. Y is U sin theta, that is determined here squared. Simplify this. Root from here U squared cos squared theta plus from here U squared sin squared theta. R dash equals root U squared can be taken out. Then within brackets sin squared theta plus cos squared theta remains, and we know sin squared theta plus cos squared theta equals 1 always. 1. Right? Keep simplifying. Keep simplifying. Keep simplifying, right? I'll write the rest here. So r dash equals root u squared, which means r dash equals u. It returns with the same initial speed. It returns with the same initial speed. That's the learning. And this is also happening. This is also happening in a symmetric motion only. If the motion is asymmetric, velocities are also different. If the motion is symmetric, initial velocities and final velocities are same. Only the directions are different. Horizontal component is same as u cos theta. Vertical component was u sin theta upwards. Here, vertical component is same u sin theta downwards. Right? And the resultant is u, and here the resultant is also u. Now, if we need the angle, I will label this angle as alpha. This is what I am going to determine. So we know always tan alpha can be written as y of x. From that previous theory you learned, tan alpha is y of x. Now y side is this, y direction is this one. Y is u sin theta, x is u cos theta. Because x is, let me write in words if needed, I mean labels if needed. Labels are y is also y and x is vc, yeah? X is vc according to my labeling. Then tan alpha is y is u sin theta, vc is u cos theta, u to u cancels. Tan alpha equals sin theta or cos theta is tan theta. We can remove remove tan from both sides. So alpha equals theta, which means angle is theta with horizontal. Angle is theta with horizontal. So that's the purpose. That's the purpose of knowing about resultants and dissolved components. That's the purpose behind knowing resultants and components. Clear? Now, go through these things again. Go through these things again, because next day we will be starting all the applications of projectile motion. We will be starting all the applications of projectile motion, and up to here, this is all about the general things in a projectile motion. General things, general approach we do. And this is a symmetric complete projectile motion. This is a symmetric motion. Right? Online students? Any questions? Is it clear? Online students? Any questions? Zoom, YouTube? Any questions? Online students? You are clear? Right. Others? Mention this with a red pen. Mention this with a red pen. Put an asterisk mark and mention this. Velocity of particle at point C. Velocity of particle at point C. Velocity of particle at point C. Velocity of particle at point C is the resultant velocity of vertical and horizontal components. Is the resultant velocity of vertical and horizontal components. Is the resultant velocity of vertical and horizontal components at C. These two are these are the vertical and horizontal components at C. These are the vertical and horizontal components at C. Right? And about determining the resultant magnitude and the direction, that is same as the theory we discussed before. Right? Always the resultant can be written as root x squared plus y squared, and angle can be written as y over x. Now this is the angle with horizontal. Now if you compare these two, now initial direction was same angle, same theta upwards from horizontal, and here same theta downwards from horizontal. So therefore these two are like mirrored directions. These two are like mirrored directions. If you mirror this direction, to this side, like this way. If you mirror this direction to this side, you will get this. And this only happens in a symmetric motion only. In a symmetric motion. If the projectile motion is asymmetric, definitely times, velocities, angles, everything are different. Clear? Right. Clear, no? Right. Okay. Then, so today, now I have finished discussing all the general things. Right? Today was the starting day of projectile motion. Now we have finished discussing all the general things about the projectile motion. And next day, the full day we will be doing all the applications of projectile motion, starting from the simple applications and towards the advanced applications. Right? So next day will be a full day of applications of projectile motion, and by next day, projectile motion will be finished. Right? Okay. Questions. So why do we find the value of tan alpha for this question? Direction is asked. I asked the direction. So direction is this. Then finally you can mention this as, velocity is u with angle of theta with horizontal. So likewise you can state this final answer. U with an angle of theta with horizontal. See, this angle is measured with horizontal. So that is with horizontal. Right? Okay. So from here, all the foundation, the fundamentals you need to know, the fundamental knowledge you have to have about projectile motion is finished. So next day we will be finishing all the applications and finishing projectile motion. And the coming week we will be starting vectors. Right? Okay, that's the plan. So I'm going to end up the class here. That's it. And no questions, no? Right. And the students who are on YouTube, you can leave a comment there whether you understood the lesson or not. Right? පාඩම තේරුණා නම් YouTube එකේ වීඩියෝ එකට කමෙන්ට් එකක් දාන්න පුළුවන්. lesson එක තේරුණාද නැද්ද කියලා YouTube වීඩියෝ එකට කමෙන්ට් කරන්න පුළුවන්. Right? For the students who are on YouTube. Okay then, since there is no any questions, I'll wind up the session here. So next day plan is that go through everything, because I'll be starting questions from the very beginning of the next day. There's nothing to discuss as theories. Now all the theories of projectile motion is done from here, right? So we'll be straight away starting questions, right? So therefore go through these things again and again, and make this knowledge solid and come to the next class. Then we'll be starting questions from simple questions up to advanced questions, right? Okay, then I'll be winding up the session here, right? So thanks all for joining the YouTube students. Okay, so see you all on the next class. In the next class, stay safe and go safe, right? Goodbye. No, add your comment to not to the live chat, to the video once the video is live stream is ended. No, otherwise live chat will be disappeared after the live stream is ended. Live chat is only visible for the live stream. That's not a comment. Live chat is a chat. Comments are the comments that we can put to the video. Now, otherwise, if the live chat remains, that's sometimes it's good, but live chat disappears once the stream is ended. Right? Okay.